just want to record down this one for Amos, because Amos is not with us today. Okay. Okay, now, so reflection happens on opaque object. So when light ray strikes an opaque object, it cannot pass through. It cannot pass through, okay? So what happens is that most of the light is being reflected off in the different direction, okay? In another direction like this. All right, now, so that is for reflection. Now, it depends on certain objects. Not all objects are opaque. Some objects are transparent, for example, like water and also glass. Okay. Now, what happened for this transparent object? If we have a transparent object, okay, let's say this is a transparent, can be glass, or water. Okay. Now, 182, Ryan, page 182. Okay, so when light ray coming from the first medium, the A, and strikes the boundary here, what happened is that three things happen. RAT, R stands for reflection. Some of the light, some portion of the light will be reflected. Yes, it will still be reflected, even though this is a transparent object. Okay, this is transparent, but it will still be reflected, but only a bit, some portion of it. Okay, and then second is absorption. Absorption, some of the light will be absorbed, and the rest will be transmission. Okay, so today we will talk about transmission. Okay, we already done reflection. Absorption, we are not going to talk about absorption, because absorption, you learned that in the heat chapter. Okay, in the previous chapter, the heat. Okay, now, so three of this still will take place in any object. Okay, but maybe if you're talking about this transparent object, maybe most of the process falls in this transmission. Okay, most of the light is being transmitted rather than reflected. Okay, so absorption only takes place. So what does absorption do to the light ray? You see, if the light comes from the ray, okay, let's say we have two boundaries. Okay, let's draw a line here. Now, first medium is A, and second medium is water. Okay, now light ray strikes here. Three processes take place: reflection, absorption, transmission. Now, absorption, it will decrease the intensity of the light ray. Okay, so I write down here, absorption decreases intensity. You can think of intensity like the brightness. Okay, like the brightness of the light ray. So absorption, when light ray changes medium, it decreases in intensity, in terms of intensity. So meaning that you have less light in the water right now. Okay, less light, because the brightness already decreased, which is why when you go deep under into the ocean, slowly it will become darker and darker, and no light at the bottom. It's because of the intensity slowly decreases, and there's no light at the bottom of the ocean or the sea. Okay, now, so transmission happens on a particular medium only a few medium where light can pass through. Remember, transparent and water, not opaque. Okay, now, when light changes medium, okay, now we are talking about transmission right now. When light changes medium from air to water, this example down here, okay, so two things will change. First one is the speed of the light will change. Second is the direction of the light will change. Okay, now you write this down, this one. When light enters a different medium, there is a change in speed and direction. Okay, write this down, everybody. When light ray enters a different medium, there is a change in speed and direction. Okay, this is transmission, guys, not reflection. reflection is different. If reflection, there's no change of speed. There's only change in direction. Okay, this is when the light passes through the object. Okay, so it has change in speed and direction, and this phenomenon is known as the refraction of light. Okay, so whenever I talk about refraction, straight away okay, there is a change in speed and direction. Now let me give you a scenario here. Okay, so let's draw a boundary. Left side medium 1, and the right side is medium 2. Okay, think of medium 1 as, let's pick any medium, A. Okay, medium 2 is, okay, let's take the same one, water. Okay, now incident ray, the incoming ray, strikes the boundary. So here, initially it is moving at a certain speed, right? We call it speed 1. Speed 1. Okay, when it enters the medium 2, still it will move in straight line like this, same direction. The direction is not changing yet in this case. Why? Because the light ray, it is coming 90 degrees to the surface here. Okay, now when light ray strikes the surface perpendicularly, meaning the 90 degree here, then the direction will not change. It will just pass through straight. All right, but in this case, only one quantity change. Which one is the speed? So here we have speed 2, different speed. These two are going to have different speed. Now, what is the speed of light in A? The first one, before it enters the medium. The speed of light is 300 million per second. Okay, this is fixed. This is already fixed. 1 second, 300 million meter. Okay, 300 million meter per second. Okay, now as it enters medium 2, of course, it's going to, what happens to the speed? It speeds up or it slows down? Speeds up or slow down? Okay, remember this. When light enters a medium from free space, what is a free space? Free space, you can think of it like vacuum or air. Okay, air, we still consider it free space. Okay, now when light enters a medium from free space, then the light speed always slows down. Okay, light speed, I repeat, when light enters a medium from free space, the speed of the light always slows down. Okay, so speed, air or vacuum. Okay, can be air also, not necessarily outer space. Can be air also. Okay, speed slows down. Okay, so from air, light ray travels from air, entering glass, entering oil, entering honey, any form of medium. The speed will always slows down. So in other words, you can say that light travels faster in air or vacuum, which is 300 million per second. Okay, now maybe you ask, how much does it slow down? The speed too. How much? Slow down by how much? It all depends on the medium. All right, depends on medium. Different medium are going to have different strength in reducing the speed. Okay, now the strength of the medium, there's a name for it. Okay, for example, if this is water, so how much it slows down the light? If water are about 25%, about 25% of the speed is slowed down. There's 25% reduction in the speed, okay, as it enters water. If you're talking about glass, if this is glass, then there's no reduction. It's about like 30%. It's about 30% reduction in the speed. All right? Different medium is going to have different strength on slowing the light speed down. Okay, now the strength of the medium that slows down the light, there's a name for it. We call it the refractive index. Everybody write this down. Refractive index. What is the medium? It will mention, for example, I say light ray from A enters a glass block. Then what is the medium? A and glass. Yeah. anything that the light travels in, that is the medium. Okay. So now refractive index. What is refractive index again? Refractive index is the strength of medium to decrease the speed of light. Just to give you a picture of a perception of what refractive index is, okay, you can think of it like the strength of medium to decrease the speed of light. Again, if just now I talked about glass and water, right? So which one reduce the light at a greater extent? The glass, right? Glass reduces 30%. Water reduces only about 25%. So if glass reduces at a greater extent, then it has a higher refractive index. Okay, simply because it has a higher strength of decreasing the speed of light. Okay, now this refractive index, again, it has a symbol. Okay, symbol. So what is the symbol? This one, the abbreviation is N. Okay, N. Yeah, N. So this N in light, in chapter light, when you see this N, it stands for the refractive index. It is measure of the strength of the medium to reduce the light speed. Okay. Now it also has a formula. This N has a formula. So N is equal to, it's very simple, it's not complicated, the formula. C and then divided by V. That's it. C divided by V. Now, what is C? C is light speed in air. Right? You might want to take down this one because this is not in your textbook. This is like an extra part, but not many, just a small part. Okay. Light speed in air, C. V is the light speed in second medium. Any medium that the light enters from air, that is the speed for V. Okay. Now, example. Okay, speed of light in air equals to 3 times 10 to the power of 8 meter per second. Okay, and then given the speed of light in diamond is about 1.25 times 10 to the power of 8 meter per second. Okay, now given the speed of light in A and in diamond, calculate, if I ask you to calculate the refractive index of diamond. What is the strength of the diamond in reducing the speed? Okay. So here, given two medium, again, so what is the medium here, Ryan? Speed of light in A, so this is the first medium, A. Speed of light in diamond, second medium. Okay, so when light ray travels, yeah, the first medium is A, depending on where is the incident ray coming. If I say when the light ray comes from the A and enters the diamond, then the first medium is A. Okay, so as light ray enters, goes through, it passes through the diamond's structure in the body of the object, the diamond. So what happens is that refraction will happen, right? So light will slow down because it is coming from free space, Okay, but how much? What is the index, refractive index? So you calculate N equals to the speed of light in air. So this one is 3 times 10 to the power of 8 meter per second. Okay, and then you divide it by the speed in the diamond. Okay, 1.25 times 10 to the power of 8. And then what is the answer? Somebody let me know.
Power 8.
Yeah, power 8.
Decimal 是
Decimal.
2.2。
2.4, right? 2.4. Okay, we take a 0, 3 significant figure. 2.40. Now, guys, look here. You see, this one, what is the unit for the speed? M/second, right? The speed in A. The speed in medium is also m/second. So when you divide it, it will cancel out each other. So the unit for n, what is the unit? 因为你除嘛，你 s 除 s 你割掉了嘛，对不对？become 1, right? So this unit, ms and ms, they will cancel off each other. So the n is left with no unit. So there's no unit for refractive index. All right. So you don't write the ms here, no. Okay. There's no unit for the n, the refractive index. It is a number. It can be a decimal. Usually it's decimal. You will see that it is decimal. Okay. So the higher the refractive index, the higher the reduction in speed. Okay. Now, if you see diamond is very high, actually 2.4. Water is about 1.33. Yeah. Wait. Let me just draw this. Okay. Water is about 1.33. And glass is about 1.53. Okay, so these are the common examples that we will use in in the exercises in the textbook. Okay, you will always see this water and glass. We'll use these two, very common, the most common one. Okay, so diamond is a lot higher. You see 2.4. Okay, so this is one of the reasons why diamond is very expensive. It is expensive. 很散 one of the reasons. Okay, so high refractive index. So you have a table of the refractive index in the textbook. Okay, page 183. I think with 183. Okay, now let me erase this. Yes. Yeah, Mr. Lim will enter the class to give some, I don't know, maybe say something about the COVID situation, because currently like there's these cases rising. Yeah, I think I think not over 100 in KK lah. If only in KK, I think not over 100. Yeah, if in KK over 100, I think everything will go back to the normal. I mean, everything will go back to online. Possible lah. The center will close down again. Okay. So I think I don't know when Mr. Lim will come in. He will come in anytime to talk about the current situation outside lah. Okay. Okay, now example two, guys. Example two. Okay, so if given the refractive index of glass is 1. Just now, what is it? Is it 1.53, right? 1.53. Okay, and the speed. What is the speed of light in glass? Again, you use the same formula. Refractive index of glass 1.53. So what is the speed? So N equal C over V. Okay. Now you have to know the C sometimes is not given to you. The C sometimes is not given. So, it is fixed. 3 times 10 to the power of 8. This is light speed, fastest one. Fastest speed in the universe. Okay, 3 times 10 meter per second. 300 million per second. Okay, this is already fixed. Okay, so 1.53 equals to 3 times 10 power of 8 over V. And then you calculate V. V 不是 fixed V 是在那个 medium 里面的Okay, the C is fixed Okay, so if you see this formula only applies for light ray that comes from A. Alright? Because we always use C, we use light speed. This C. This formula only applies for light that enters the medium from A, from free space. Okay, from free space. Because the speed, we always take the speed of light in A, 3 times 10 power 8. Okay, now I'll erase this and we'll go to the next part. Okay, now, so guys, just now we talked about the change in what? There are two changes, right, in refraction. First one is the change in speed, and second is the change in direction. So just now we talked about the change in speed, and now the change in direction. Okay, so suppose that we have, again, a boundary. So this is medium 1. Okay, from now on, I'll just write M1 for medium 1. Okay, take it capital, M1. Okay, this is medium 1 and medium 2.
The line from M1 to M2 is invisible.
No, I mean, all this, the interface, the surface, for example, light, when light enters this thing, this object, the line is where? This one, outermost surface. Okay, the outermost surface. The line that separates the two medium. Okay, that is the interface. Okay, now let's say you have a incident angle, incident ray, okay, incoming ray, incident ray strikes the medium here. Okay, as usual, we are going to draw a normal. Okay, so the normal is perpendicular to the surface here. Now, what is the difference between this one and the previous one? Okay, the previous one is the incident ray is coming to the surface perpendicularly. All right, so if I draw, this is the surface, the boundary. The light ray is coming like this. Like this. Okay, so here is perpendicular, right? So this is perpendicular. I mean the angle is perpendicular. Okay, so if perpendicular, there's no change in direction. There's only change in speed. So this one is different. This one is coming at an angle. There is an angle of incidence. Where's the angle of incidence? Here, right? This is the I. It's always the angle between the normal. I cannot emphasize this anymore. This one, I have to keep remind you that the angle is between the normal and the line, not the surface. Okay. Now, this one is coming at an angle. So in this case, it will change its direction. Is there any change in speed? Yes, both. Change in direction and change in speed. Okay, now if I draw the original path of the light, it's like this, right? This is the original path. Okay, let's use it pink color. Okay, let's just use just black, just black. Okay, this is a dotted line. Okay, think of this like a imaginary line, dotted line, just showing the original path. Okay, just to let you see the difference. Okay, the light ray, the real ray that comes out after this medium, it should be bent downwards like this. Okay, the blue ray is the correct one, not the black one. The black one is just showing the original path. Okay, so what you will see when it enters this second medium, the light ray will deviate to this blue ray.
From the black one.
Yes, from the black one to the blue one. The black one is the original path. Okay, it is bent downward. All right, this we call it the bending of light. Okay, refraction. Okay, now where is the angle of refraction? Okay, if I extend the normal, the angle of refraction, again, it is between the ray and the normal. Okay, angle is always between the normal. Okay, write this down here. This is the incident. We still call it incident ray. And this is angle of incidence. Now, the blue ray is the refracted, not reflected, is refracted ray. Okay, so if this is the refracted ray, then what is the angle called? the angle is called the angle of refraction and not the angle of reflection. Okay, there's a difference. Reflection.
So what's the difference between refraction and reflection?
Reflection is kwantan. Refraction is go through. Okay, refraction is it passes through, and it only happens for certain subject, like transparent. Only then it can pass through, right? Can it pass through this wood? No, right? Okay, so angle of refraction, refracted ray, and all this. Okay, now, so whenever light ray travels from an angle to the boundary, then there is a change in speed and direction. If the incident ray lies on the normal line like this, is along the normal line here, it will go straight down without change in direction. Okay, now the turning, guys, you have to look at this, guys. Where does the turning takes place? Where does the turning happen? Over here, right? Over at the center here, the X point here. This is when the turning happens here, not here, not here, here. Okay, so meaning that the turning happens when there is a switch between the boundary.
Only if the direction is this.
Yes. So my point is that the light ray it will maintain the same direction in the same medium. Okay, so you see in medium 1, the same type of medium, it will keep traveling straight until it hits another medium. Then only the turning takes place and it changes its direction, and it will keep on moving in this direction, this blue ray, until another medium strikes it. Okay, until there's a change in another medium. Okay, so if I draw like this, let's say we have 3 layers, 1, 2, and 3. Okay, 3 different medium, medium 1, and then medium 2 and medium 3. Medium 3. So light ray will keep going straight until striking a boundary. So it will change its direction like this, and it will also keep going straight until it strikes another boundary and changes direction like this. Okay, so in any one medium, the direction is the same. The turning only happens between medium. Okay, now let me do this. So this particular example, the light ray bent downwards. Is there any case where the light ray is bent upwards? Yes. Okay, yes. So okay, second scenario. This. Again, this is the draw the light ray. This, okay, the normal line, original path is here. Now, in some cases, the light ray will bend upward, like here. Okay, so this is the arrow here, and this is the. Remember, always put the arrow. Without the arrow, then that is not light. Okay. So in some cases, it will bend like this. This is, we call it bends away from normal. I don't want you to use the word upward and downward. No, because if I change the position of this one, then it changed also, not upward and downward. We use away from normal or towards the normal. Towards normal. Okay. In the first case, it bends towards the normal. Second, it bends away from the normal. Okay, so if it bends away from normal, where is your angle incident? Angle incident is still the same here. This is I. Angle of refraction from the light, from the blue ray, all the way to the normal, R. Angle of refraction. Okay, so this angle of incident and angle of refraction are not going to be the same. In your reflection, what you learn about the I and the R is always the same, right? But for refraction, it is not the same. Okay? It is not the same because of the bending. Okay, now the big question: which one how do we, okay, how do we determine whether the light will bend towards the normal or away from the normal? We look at the refractive index. Okay, we talked about the refractive index. What is the refractive index, Ryan Tan?
Going like
What is the refractive
one
index?
medium to the other medium.
No, it is a measure of what?
N over Q. N equals Q over V.
Yeah, that's the formula, right? But N is what? It is the measure of what? Strength to slow down light speed. It is a measure of the strength of the medium to slow down light speed. Okay? Now, so when light comes from A and enters a high refractive index medium, okay, listen here. When light ray comes from free space, okay, look at the left picture, this one. Comes from free space and enters a medium that has a high refractive index. Okay, so this medium, medium 2 is high refractive index. What happens to the light? It slows down, right? It slows down. So as the light slows down, it will bend towards the normal. All right. So second case, the picture on the right, when light coming from a medium, okay, it's not a medium, and enters a medium which has a lower refractive index, then light speeds up and it bends away from the normal. All right, now I repeat, guys, when light enters a medium with high refractive index, the medium will slow down the light, and then the light ray will move towards the normal. Okay, so when light ray enters a medium with a lower refractive index, then the light speeds up and it bends away from the normal. Now I'm going to write this down for you to just take down. Okay, if light high refractive index enters a medium I think I'm just going to end this meeting and create another one because there's less than 1 minute.